Okay, so can you hear me? Let's start. So let's continue our discussion about the applications of diodes. So ngayon, you'll be learning about diode limiting and clamping circuits. Let me proceed to the objectives of this lesson. So after completing this section, so you should be able to explain the operation of diode limiters or clippers. Second is to determine the output voltage of a biased limiter or limiter. The other term for this is clipper. Use voltage divider bias to set limiting level. Explain the operation of diode clampers. So if we have enough time, we can be able to discuss clampers later. Okay, so let's start. So what is a limiter or clipper? So a limiter or a clipper is a diode circuit that clips off or removes part of a waveform above and or below a specified level. So take a look at this example circuit. So you have an AC input. Yan. Meron tayong resistor, R1, and a diode. And then you have a resistor here in parallel to the diode, denoted by R sub L. So this circuit shows you the input waveform and the output waveform for this diode circuit. As you can see, yan, nabanggit dito sa letter A, limiting of a positive alternation or kiniklip niya yung positive half cycle. Yan. So the diode is forward bias during the positive alternation, yan, above 0.7 volts, and reverse bias naman during the negative alternation. Okay, so explain ko lang in Tagalog dun sa mga nanonood. So yung input natin is an AC input. So meron tayong positive and negative na alternation or negative half cycle. So yung pinaka-peak value is labeled as VP. Ayan. V in, ito yung input voltage natin. So in analyzing the circuit, we consider, diba, yung positive half cycle, ano yung nangyayari dun sa output? Pag negative half cycle, ano yung mangyayari sa ating output? As you can see, yan, kapag positive half cycle, ibig sabihin positive yung voltage natin. So what will happen to the diode? Will it conduct current or not? So ganitong case na yung input natin is V is positive, yan, V peak or VP, yung diode is in forward bias na condition. So ibig sabihin, magkakonduct ito. So kapag ideal yung diode natin, so short lang yung lalabas dyan. Yan. Parang wire lang din. So 0 voltage. But if it is a silicon diode, yan, practical na consideration. So meron tayong diode voltage which is equivalent to, kapag silicon, 0.7 volts. Okay, so mababasa natin dito, since mag-forward bias, itong diode na to during the positive half cycle. So if we connect, ayan, check natin sa oscilloscope, diba, yung output waveform natin, we will connect here our measuring instrument para ma-read niya yung mismong level. Ayan, so you'll be reading ano yung voltage across the diode. So yung RL pala na to, since diba yung resistor na yan, are represented by R sub L, yung load natin. So wala ka ng ano dyan, walang current dito. So ang mangingibabaw is the voltage na mababasa natin, or we are actually measuring the voltage across this diode. So practically, this is 0.7. Kaya ang mababasa natin sa output, yan, is positive 0.7 during the positive alternation. Ngayon, syempre, we have considered yung positive half cycle. Ngayon, we will consider the negative half cycle. So kapag negative half cycle, anong mangyayari sa diode natin? The diode is in reverse bias. So ibig sabihin, open circuit ito Pag open yan, walang current, right? Nadadaloy dito. So ano yung mababasa natin na voltage? Yan, anong output voltage natin? Since we have RL here, yung level ng output natin during this na negative alternation, yan, is based dun sa, ayan, voltage drop dun sa RL. Okay? So gagamit tayo ng voltage divider dito. Okay? Pero, yun nga. So how do we determine the voltage across here? Since we have an input voltage na and in negative na polarity, so negative VP, multiply lang natin doon sa RL divided by the total resistance, which is the sum of R sub 1 and R sub L. So, kuha ko ng ballpen para. Yan, naririnig niyo pa ako, guys? Hindi naman nawawala yung connection ko.
Hindi naman po.
Ayan, alam niyo ba yung voltage divider? No? So, ang mangyayari kapag negative half cycle, yan, ito yung ating consider. So, negative voltage yan. Yan yung papasok dito. Naka-reverse bias, ito, yung diode natin. So, the circuit, equivalent circuit will be, ito yung R sub 1. Tapos, yung diode mo, yan, open lang siya because of, the reverse bias condition. Walang current dyan. Tapos meron kang load RL dito. So R sub L. Ayan, naka-ground yan. So basta yung input natin is negative. Right? So input is equal to negative VP. So yan yung papasok sa circuit natin. So ganun yung flow ng current natin. So negative VP para makuha natin yung voltage, kasi ito yung measure natin yung voltage output or voltage across the load. So yan, measure ka dito. Meron kang positive and negative na leads dyan connected to the load. So it's as if that you are measuring the voltage drop here in R sub L. So paano ba yun, sir? Kaya nga yung voltage divider na sinasabi ko. So sa voltage divider, para makuha yung voltage output, tandaan na voltage output is equal to the voltage drop across the load load resistance. So, and that is what? Input, which is negative VP times the R sub L all over, total resistance. So that is what? R sub 1 plus R sub L. So ito yung voltage divider. Ganun di ba kapag series yung connection natin? Tulad nito, R sub 1 is in series with R sub L. Yan. So yung sum ng voltages nila is equal to the input voltage, itong negative VP. Nakuha po ba? So isang current lang yung dumadaloy dyan kapag series yung connection. Okay? So kaya ang nakita nyo dito, yung output, wait lang. Output natin is this one. Negative, during the negative half cycle. So para mas makita nyo, di ba, bakit ito yung level? Bakit parang similar to negative VP? Since magbibigay ako ng value na lang ha. So let me give an example here. So R sub 1 natin, say for instance, 100 ohms. Tapos yung load resistance natin, say for instance, is 1 kilo ohms. Yun yung value ng RL natin. Tapos yung VP natin is equal to 10 volts. Yan. So negative VP is negative 10 volts, right? So, okay, nasundan ba? So doon tayo sa negative alternation kasi alam na natin na lalabas na output dito, and considering that this diode is silicon, 0.7 yung output natin. Yan, kasi isa-sketch niyo yung mismong output waveform for this type of circuit. So 0.7 yung output natin. Ngayon, we are going to determine yung level nitong output natin during the negative half cycle or negative alternation. So negative 10 volts, may formula na ako na binigay. So yung output na mababasa natin. So V out is equal to negative VP is negative 10 volts. Yan, negative VP. Kasundin mo lang talaga yung, ayan, yung numerical value. So negative 10 volts times RL ko na 1 kilo ohms or 1,000 ohms divided by the total resistance kasi naka-series sila, di ba? So 100 for R1 plus 1,000 ohms for RL. Yan. So negative 10 times 1,000, calculator na lang. This is negative 10,000 over 100 plus 1,000 is 100, 1,100. Yan, cancel lang natin yung mga zeros since, yan. So 100 divided by 11, our V out is what? Negative value to. So 9 point, calculator, 9.09. Tama ba? Or 9.1, which is approximately equal to the V peak which na 10 volts. So nakita nyo, yung level ng output natin is yan. It's negative 9.09 volts. In cases na, yan, kung wala man tong, yan, ganun lang yung idea. Kung wala man itong load na to, so ang mababasa mo is kung ano yung input mo. Nakuha, so kung wala tong load na to, resistor, you'll be reading negative 10 volts dun sa output mo. So negative 9.09, so malapit sa negative 10 volts. So ito yung output nitong circuit na to. So since clipper nga or limiter, ano yung pinaka natutunan nyo dito? Sabi nga, di ba, nire-remove niya or kiniklip niya or nililimit niya yung part ng waveform. Di ba, we have this input. May positive half cycle and negative half cycle. Di ba? Sinusoidal yan. So yung lalabas doon, di ba, pagka ito yung input natin, anong nangyari doon sa positive half cycle? Na-clip na siya. So yung level na mababasa mo is kung ano yung diode voltage. Kung ideal yan, so 0 lang, yan, DC, or 0.7 kapag silicon type na diode. During the negative half or negative alternation, negative yung input mo, yan, naka-reverse bias si diode. So open circuit yan, ang nababasa mo na voltage, kung wala tong RL, is yung input mo. Since may RL ka, so gagamit ka ng voltage divider to determine the voltage across RL or R sub L. So yun lang. This is, ang tawag sa term na sa type ng circuit na to is positive clipper. Bakit positive clipper? Kasi yung positive half cycle, yung ni-remove niya dun sa waveform. I mean, positive, tinanggal niya or parang ni-remove or clip niya. Ni-clip niya yung mismong positive half cycle. Okay? Kaya yun yung term, di ba? Positive clipper. Or in terms of the connection, yung pagka-construct sa circuit, parallel naman. Kasi may dalawang klase ng clipper, di ba? Based on the output. Yan. Tapos based on or a type of clipper in terms of its connection. Yung una, kapag based on the output, so merong positive and negative clippers. Yan, pakinote na lang guys ha. Tapos kapag based on the connection, meron tayong series na clipper and meron tayong parallel clipper. So later, may mga examples tayo dyan. Okay, so let me proceed to the next page. Ayan, so ito naman, yung example ng circuit natin na yung negative half cycle naman, yung naka-clip or ni-remove. Do you follow? So in this case, yan. During the positive alternation, yan, positive volts, positive input voltage. Ano yung orientation? Si diode ba ay naka-forward or reverse bias? So positive, connected to the cathode, yung diode mo is in reverse bias. Okay, so dahil reverse bias to, open siya. Kaya anong nangyari dun sa output mo? Kung wala tong load, ang nababasa mo is the voltage or yung input, basically. So kung ano yung value ni VP mo, yun din yung output na mababasa mo during the positive half cycle kasi naka-reverse bias si diode mo pag reverse bias. Anong ibig sabihin nun? Walang current, di ba? So this diode does not conduct current. Ngayon, kapag negative alternation, yan, negative yung voltage input, yung input voltage natin, anong orientation ni diode mo? Anong consideration natin dito? Naka-ano siya, naka-forward bias siya, 'di ba? The negative polarity of the input is connected to the cathode. So negative, negative, the same polarity, 'di ba? If you remember yung ating basic na or intro here, anong mangyayari? Naka-forward bias, magka-conduct siya ng current. Kasi yung idea ng diode is, 'di ba, parang it will allow the current or electrons to flow, the free electrons to flow. So yan. So kapag negative ang input natin, itong diode na to, gagana siya. So kapag ideal condition, yung diode voltage mo is 0. Pag practical, say silicon diode ito, so you have 0.7 na diode voltage or threshold voltage or the barrier potential. So yun yung other terms. Kaya ang nakita nyo dito, since naka-forward bias siya, yan, negative ang in-apply natin na voltage. So this is negative 0.7. Kaya you will be seeing here in your output negative 0.7 during the negative alternation. So ang nangyari, ni-clip niya yung mismong negative half cycle. So this is an example of a negative clipper or negative na limiter. Yun yung other term. Kasi ni-clip niya yung negative na half cycle ng waveform or input natin. Okay po ba? Questions? None? So, ayan, let me show you here. Andyan pa ba kayo? Can you still hear me?
Yes po.
And so this is the formula that I have introduced earlier. This is how you determine the output voltage, yung level ng output natin kapag naka-open yung mismong diode. Tapos we are measuring the voltage across the load resistance, yung RL. Kaya ito yung voltage divider, guys, na formula. So Vin or input voltage, yan, multiplied to RL. Ito mawala. Yan. Okay, yan. Vin times RL over R sub 1 plus RL. Ito yung total resistance. So yan. Sabi dito, if R sub 1 is small compared to R sub L, then the V out is approximately equal to V in. Kaya nga diba sabi ko, pag ni-remove natin yung RL na yan, tapos i-measure lang natin yung voltage doon sa diode, kasi naka-reverse bias siya, so wala kang mababasang, walang current, so ang nababasa mo, so the entire voltage is actually the input. So yun yung lalabas. So ito naman, kapag may RL ka, kapag napakaliit ng value nitong R sub 1, if R sub 1 is very small, so negligible na, so parang approximately equal siya dun sa V in, yung output na mababasa mo approximately equal to, which is kanina, di ba na pinakita ko, yung 10 volts na input, yung negative 10 volts, basa natin or na-measure, na-compute natin is 9.09 doon sa output. Okay, so let's continue with another example. So what would you expect to see displayed on an oscilloscope connected across RL in the limiter? Limiter is another term for clipper. Yan. Ito yung given circuit. So we have an input na plus 10 volts during the positive half cycle, negative 10 volts peak, yan, so negative half cycle. Or basically, pag peak to peak value, this is 20 volts yung input natin. 20 volts peak to peak, 10 volts peak value. Okay, so the R sub 1 is 10 kilo ohms or 10,000 ohms. Yung R sub L natin is 100 kilo ohms or 100,000 ohms. So yung V out mo, yan, itong blue na arrow na to. So this portion, or para ma-measure natin yung V out, so you have to connect your oscilloscope here. Yan. Oscilloscope is a measuring instrument. It will display yung waveform ng ating output. So pwede rin yung input, yan, as long as diba, you utilize 2 channels. The first channel for depicting the input, and channel number 2 or the other channel will be utilized to display the output waveform. So yan, pwede nyo gamitin yung multisim to simulate yan, this type of circuit para makita nyo, okay, nag-clip nga siya sa negative or sa positive half cycle. So yun. Okay, again, yung pinaka-definition ni clipper is it clips off or removes yan, part of the waveform. Yan, tingnan natin to. Yan, familiar, no? Ito yung previous example lang, may mga values. So 1N914 is a silicon type na diode. So kapag AC yung input, we consider, di ba, positive half cycle or positive alternation and the negative half cycle or negative alternation. Okay, so first, kuha ko ng pen muna. Kamusta? Okay pa ba? Nasundan naman?
Medyo, sir.
Sige, let's have an example para yan, mas makabisado natin itong clipper na to. So, anong klase ng clipper to, guys? Based on the connection. Ito ay, yan no, parallel clipper. Yan. Mamaya malalaman natin kung ano ba siya, negative or positive clipper. Kung kiniklip niya ba yung positive half cycle or yung negative half cycle. So what will we be doing is, examine natin. So during the positive, shade ko lang yung positive alternation or the positive half cycle. So during this, this stage of or the process, so yung input natin is what? During the positive alternation, positive 10 volts. Okay? So positive 10 volts, positive voltage, guys, tingnan mo yung orientation. Ayan, pagkaka-connect ni diode. So kapag positive, tapos tingnan mo, cathode ito. So unlike yung polarities nila. So positive polarities connected to the cathode, this diode is open. Naka-reverse bias. Kaya, ayan, ano yung output voltage na mababasa mo kapag ganito yung case? Ayan, so kapag open ito, ayan, tanggalin na natin itong diode na to, your current will flow, ayan, will actually pass through RL. Andyan yung current mo. So, dito mo, yung other way is yung kanina, di ba, if you remember yung voltage divider, pag alam mo na yung current, so pwedeng current times resistance, yun ang mismong output voltage. Or, para mas madali nga, yung formula kanina ng voltage divider, so that is how you determine the output voltage. Sige. Kung wala tong RL, ang mababasa mo na voltage is kung ano yung input mo. Okay? So, dito ang tinitignan natin, or ang tinatanong kasi, di ba, ano yung makita mo dun sa oscilloscope, yung display. So, basically, output waveform. So, i-label natin siya. So, the vertical axis, vertical or y-axis is our V out or VO, lagay mo dyan. Tapos against time. Yan. Silicon. Assume natin silicon to. So we have a barrier potential kapag gumana si diode, 0.7. Dahil sa during the positive half cycle, naka-reverse bias si diode, walang current dito siya dadaan sa RL. Ang mababasa natin is the voltage across R sub L. And what is that value? So gamit yung voltage divider na formula, so V out during the positive half cycle or VO is equal to V in times R sub L. Bakit R sub L? Kasi yun yung i-measure natin yung voltahe dito sa RL over the sum of the resistances or the total resistance. So R sub 1 plus R sub L. I-plug in natin yung mga values. So VO will be V or V out. V in is positive 10 volts. R sub L is 100 kilo ohms. Ayan, so that is 100,000. 100,000. All over, ayan, 10K plus 100K. Ano yan? 110,000. Okay? So cancel na natin yung mga zeros kasi naka-product form naman. So possible yan. Tatlo, isa. So this will be 10 times 10. So you have 100 divided by 11, which is, yan, same lang kanina, no? So 9 point, may calculator ba kayo? Baka hindi nyo tine-check ka. So it's 9.09. So check natin, 100 divided by 11. Yan, 9.09 volts. Okay, so ano yung lalabas dito sa output natin? Ayan, lagyan mo ng this, ayan, half wave. Ayan, the peak value is 9.09. Okay? So after we consider the positive half cycle as our input, ngayon naman, sige, mag-change tayo ng color ng pen into, ayan, ibang color, blue. Blue naman. So negative naman, negative half cycle. So negative 10 volts ang input natin in this case. So V in is equal to negative 10 volts. Ano yung output natin? So tingnan mo natin kung gagana ba si diode. So negative polarity connected to the negative, or the cathode. Itong diode natin, ito yung cathode niya, ito yung anode. So this diode will conduct current. So kapag mag-conduct siya, short lang yan kapag ideal condition. Dahil sa ito ay, i-redraw ko na lang guys. So kapag negative 10 volts yung input mo. So you have R1, tapos yung diode mo, ayan, ito yung negative, di ba? Cathode. So parang battery lang yan, 0.7, negative, positive. So kapag gumana si diode na to, tapos meron kang resistor dito, wala nang effect. Ito, wala nang silbi yan. Diba? You can actually remove that kasi ang mangyayari dyan, walang current dito. Nagets po ba? So ang nababasa mo, if you are to measure the V out, is actually the voltage, yung mismong diode drop, which is 0.7. Kaya ang lalabas dito, yan, check the polarity. Since negative yung input, negative 10 volts, ang nababasa mo dito is negative 0.7. Ayan, medyo exage lang, medyo malaki. So ito, negative 0.7 yan. So this is, ayan, your answer. Okay? Saan siya nag-clip? Saan na-remove yung part ng waveform? Sa negative half cycle. Nakuha? Kaya ang tawag sa circuit na ito is negative clipper. Kasi ni-clip niya yung negative half cycle or negative ng waveform natin. Okay po ba? Hello? Questions? None? Okay, kung walang tanong, let's proceed now to the next slide. Laser pointer. Ayan, biased clippers. So what if meron kang bias dyan? So tandaan niyo yung bias is an application of a DC voltage. So meron kang DC voltage dito. Let me first read yan. The first one here is positive clipper. So ano yung parang in-expect mo dito kapag positive clipper? Yung positive half cycle, yun naman yung ni-remove sa waveform natin or ni-clip niya. Ayan, basahin natin yung bias clipper. Bias clipper or bias limiter. So the level to which an AC voltage is limited can be adjusted by adding a bias voltage. So denoted by V bias in series with the diode. So yung bias natin or yung DC voltage is naka-series siya sa diode. So just like this circuit. So diode, yan, ito yung symbol ng DC voltage or battery, yan. Okay, the voltage at point A, ito yung point A, must equal V bias plus 0.7. Yan, kapag silicon diode. So if you are to measure the voltage from point A, from this point up to the ground, ayan, point A to ground, ang nababasa mo is V bias plus 0.7. Kapag yung bias voltage mo is positive. Yan. So yan, positive bias plus 0.7. Kung negative naman, baliktad yan. So minus V bias plus 0.7. Okay po ba? Ayan. So may dinagdagan lang natin siya ng bias voltage. So syempre, nakita mo naman yung level, di ba? Kunyari, V peak siya. Example tayo, maglagay tayo ng value ng input natin. May numerical value. Yan. Say for instance, low. Yan. Yung input natin is, sige, 10 volts ulit. Tapos yung bias natin, say for instance, 2 volts. Okay? So during the positive half cycle, positive V peak yan, positive 10 volts, ayan, gagana si diode, right? So meron kang positive 0.7 dyan. So yung equivalent circuit in terms of, i-redraw ko na lang So ito R1. Kapag gumana si diode, so meron kang positive 0.7 dyan. So this is how you write. Yan. 0.7 yan. Plus, minus. Tapos meron kang DC, voltage or bias voltage, equivalent to, lagay ko dyan, 2 volts. Yan, ground. So, itong point A na to, ayan, itong node na yan, if you are to measure the voltage from here, ayan, ang nababasa mo is V bias plus 0.7. So, kaya ito na yung value. So, yung V in natin na 10 volts, ang babasa mo doon sa ating waveform will be, ayan. Wala naman tong effect ng 10 volts kasi ito lang naman na may measure mo eh. The voltage here. So, 0.7 plus 2 volts, the level here is, ayan, 2.7. Ayan, nag-clip siya. Ganon. Di ba ganito kapag complete yung waveform? Ganyan. So, this is 2.7, positive 2.7. Okay, do you follow? Ngayon, kapag negative half cycle naman natin ko consider, naka-reverse bias si diode, so open ito, ang mababasa mo na voltage kapag masyadong maliit si R1 is approximately equal to the input voltage. Okay? Tandaan nyo yun na kapag masyadong maliit, masyadong malaki yung difference nila, like 100 ohms compared to RL na 1 mega ohms or 1 million ohms. So negligible na yung effect actually ng resistance. So yung level na mababasa mo dito is equivalent to the input, which is negative V peak. So kung negative 10 volts ito, negative 10 volts ito. Okay? Pero kung halimbawang may significant difference na, ayan, na hindi ganun mababa lang, or significant yung difference pala. So pwede mong i-calculate using the voltage divider. So yung voltage divider, para makuha mo yung V out is, again, V in times R sub L over R1 plus R sub L. That is voltage divider. Meron ding voltage divider kapag current. Meron din palang voltage divider kapag yung sa DC circuits niyo pala. Ayan. Meron din palang current divider. Yun yung ibig kong sabihin. May voltage divider, may current divider. Sa current divider naman, kapag parallel yung connection, di ba? Kasi yung current mo mag-split siya. Ayan. Tapos na ba kayo doon sa DC, sa circuits niyo? Networks. Question here. Positive clipper, kasi positive half cycle, or no, positive ng waveform mo yung ni-remove or nilimit or naka-clip. That's the idea. Ayan. Negative clipper naman, wag na tayong laser pointer na lang. So yung nilimit na naman dito is yung negative half cycle. As you can see, during the positive half cycle, kita nyo ba yung laser pointer? Yung kulay pula.
Kita po,
Pula ba yung nalabas? Ayan. So during the positive half cycle, si diode is in reverse bias. So walang current dito. So open yan dyan. Ang nababasa mo yung voltage is the voltage across RL. Or if R1 is too small, the voltage here you will be reading is equivalent to the positive peak value, which is, ito. Kaya nakita niyo yung drawing, no? Same pa rin siya. Ngayon, considering the negative alternation or negative half cycle, so negative voltage, tingnan mo si diode, gagana ba siya? Gagana siya, naka-reverse bias siya. Okay? Tapos, meron ka ditong DC or bias voltage. Yan, so negative, nakalagay ito negative eh. So negative, kunyari negative 2 volts. So negative 2 volts plus negative 0.7. So this is the level or your output na makikita mo sa oscilloscope mo. So, negative V bias minus 0.7. Negative limiter or negative clipper siya kasi the negative half cycle of the waveform is being limited or clipped. Okay na po ba? Clear na tayo dito? Naintindihan? Sorry.
Okay naman po, sir.
Ayan. Okay, shout out to those are watching. Let's now move on to this example. Ayan. So basahin ko lang to. By turning the diode around, yan, the positive limiter can be modified to limit the output voltage to the portion of the input voltage waveform. Yan, above V bias. Yan, minus 0.7. Yan, similarly, the negative limiter can be modified as well. So nakita niyo, di ba, iba na yung output niya. Kanina, ito kasi, ito yung negative na, negative clipper. But because of the bias, nakabaliktad yung bias mo, positive siya. So, magbabago na yung level kung saan siya mag-clip. Okay? So, sundan mo lang nga, pag positive alternation, the output is, ayan, open ito. So, kung ano yung input mo, yun yung mababasa mo dito. But during the negative half cycle, gumagana tong si diode natin. So, negative 0.7 plus, naka-positive yung bias mo. So, say for instance, 5 volts. Yan, sabi ko hindi ako magagamit ng pen eh. So, kuha lang ako ng pen. Colored. Red. Yan, for example, yan, 5 volts ito. So, ang mababasa mo na output during the negative half cycle, dahil gagana si diode mo, ganito kapag niredraw mo guys, so, ayan, so negative, positive. Ayan. Positive, negative. So this is 5 volts. So pag binasa mo yung output mo, dyan. Yan, parang ganun yung dimension. So 0.7 ito. So negative yung polarity, negative 0.7 plus 5 volts. That is what? 4.3. Positive 4.3. So nasaan siya? Nasa positive, nasa upper part, di ba, ng axis natin. Kasi yan, drawing natin. Dito yun. Ito yung level na 4.3. Positive 4.3 volts. Eh dahil sa input natin AC, hindi lang naman isang cycle yan eh. Madaming cycles yan, di ba? Alternating. Kaya continuous yan. Yung lalabas dun sa oscilloscope na makikita mo is ganito. Oh. Ganon siya. Okay? Nakuha po ba? Ito naman, no, kapag ito, mag-clip naman siya dapat talaga sa positive half cycle, eh dahil sa meron kang negative na bias dito. So, ito yung mababasa mo sa output. Yan yung effect ng bias. Kapag magkabaliktad sila, magkaiba sila ng polarity. Questions? Okay, example tayo. So, paano kapag ganito yung circuit mo? So, take a look at this circuit. Meron kang diode na nakaparallel. Tapos each diode may naka-series na bias voltage. Ayan. Sabi dito, di ba? This figure shows a circuit combining a positive limiter or positive clipper with a negative limiter or negative clipper. Determine the output voltage waveform. Ayan. So yung input natin is 20 volts. Ayan. Pag peak to peak. Ayan. 20 volts peak to peak. 10 volts siya, positive half cycle. Negative 10 volts siya during the negative half cycle. So, ang hinahanap dito is the output voltage waveform. So, drawing natin siya. So, this is, the vertical axis is for the output voltage, ayan, in volts. Ayan. Since isang cycle lang naman yung binigay, pwedeng isang cycle lang din yung ating output, di ba? Kung dalawang cycles yung hinihingi, so syempre, i-project mo yung dalawang cycles. Yan. So, sige, tulungan niyo ako dito. Meron tayong dalawang points, ha? Isang point lang naman pala. Point A. Ayan, kasi the other diode, anong idea niyo dito? During the positive alternation, yung isang diode dyan gagana, yung isa, hindi. Kasi magkabaliktad sila, magkaiba sila ng orientation or pagkakakonect. So, ano yung gagana dyan? Lagyan ko ng label, 1 tsaka 2. So, during the positive alternation, positive yung input voltage natin, ano yung gagana? Yung diode ba sa 1 or yung D1 ba or D2?
D1 po.
D1. Okay? Kasi nga naka-forward bias yung D1 mo kapag yung input is positive voltage. Okay na. Ngayon, during the negative half cycle, ano naman yung gagana? D2. Okay, kasi yung negative input natin will actually forward bias D2. Yung D1, naka-reverse bias naman siya, kaya open lang yung ating diode sa yan, yung D1 natin. So ano yung output na to, sir? May bias ka na positive 5 volts connected to D1, tapos negative 5 volts naman connected to D2. Okay, madali lang to. Alam niyo na yung magiging output nito, guys. Sige, drawing ko na lang muna yung pinaka-waveform. Ito yung input natin, yung kulay pula is input. So, ibahin ko yung color. Wait lang, guys. Kulay blue. Ayan. Sige, lagyan natin ng label. Ito, input yan. Displaying the input voltage. Okay, during the positive half, wait kung nasaan na. Ayan, during the positive half cycle, ito, naka-open. So, ang nababasa mo na voltage from point A to ground is yan, positive 0.7 plus 5. So, that is what? 5.7. So, 10 volts ang level na to, di ba? So, saan yung 5.7? Kung ito yung 5, so somewhere here. Ganon. So, bale, ito yung output ng clipper natin. Yan, so, 5.7. Do you follow, guys?
Yes po.
During the negative half cycle, so negative input natin na negative 10 volts. Si D1, naka-reverse bias. So, ang gagana naman is yung diode. Ayan, D2. So, D2, ano yung value ng voltage na to? So, negative 0.7. Kasi negative yung input mo. So, negative 0.7 plus negative 5 volts, yung mababasa mo dyan is negative 5.7. So, ito na yung output natin during the negative half cycle. So, ito yung combination ng positive and negative na limiter or clipper. So, ito na yung output natin. So, okay na po ba? Gets? Hello?
Gets po, sir.
Okay, sige. Let's now... I think ito na yung last na ano natin. Check natin yung next slide kung anong meron. Okay. So, kanina nabanggit ko yung clippers or limiters. Yan, dalawang klase yon. In terms of the output, so yun yung positive and negative clippers. Tapos in terms of the connection, yan, ito naman yung series and parallel clippers. Okay, so paano ba yung series connection, sir? Ito yun. Yung diode mo, yan, mas nauna siya, circuit. Tapos ang output voltage mo is basically naka-series siya doon sa diode. So ito yun, nakita nyo, guys. So kapag series yung connection, yan, the diode in a series clipper clips any voltage that does not forward bias it. So ano yung mga cases na hindi niya i-forward bias yung diode, na hindi gagana si diode? Siyempre, reverse biasing polarity. Kapag magkaiba sila ng polarity. Second one is a forward biasing polarity less than 0.7. So, positive naman, kunya ito, positive yung input mo, pero less than 0.7 naman siya, hindi niya kayang i-drive or paganahin yung diode mo kasi 0.7 yung limit nga, di ba? Yung parang barrier or threshold voltage. Kaya ito yung mga conditions na hindi magpo-forward bias yung diode natin. So, yun lang. Alam niyo na to ha, kapag positive alternation, gagana si diode as long as greater yung input mo to the greater siya dun sa diode voltage na 0.7. So, ito. Ito yung input natin. Guys, ipasok natin tong input na to. Square wave siya ha. So, positive V. Pag binasa mo yung voltage dito is basically, ang gagana ito. So, ideal kunyari yung diode mo. So, short lang yan, wire lang yan. So, you are measuring a voltage equivalent to the input. So, ito na yung makita mo dun sa output waveform natin. During the negative half cycle, so ito yung condition na yung diode ay naka-reverse bias. So, dahil sabi nga dito, di ba, series clipper clips any voltage that does not forward bias it. So, ito yung voltahe, negative voltage, na hindi makakapagpa-forward bias sa diode. Kaya, yun, na-clip niya yung part ng waveform na yun. Okay po ba? So, ni-clip niya yung negative half cycle. So, ito yung circuit na series clipper and yan, negative of the waveform yung ni-clip, yung nilimit niya. So, ganito naman kapag triangular yung input natin, triangular waveform. So, yun lang. Yan, biased clippers. So, the inclusion or the adding of DC source. So meron tayong DC na positive 5 volts connected here dun sa diode natin. Tandaan na naka-series, ito, series clipper siya. Pag nauna si diode. Kasi diode is in series with yan, the resistor. So dito mo binabasa yung ano mo, output mo, guys. So ano yung effect? Yan, considering the ideal condition na ideal sa diode mo, so zero yung barrier potential. Ngayon, kapag meron kang DC dito, so anong mangyayari? Sige, during the positive half cycle, 20 volts, di ba? Gagana si what? Gagana yung diode natin. So kapag ideal ito, zero yung voltage dito. Okay? So 20 plus what? 5 volts. So ang nababasa mo na voltahe is basically ganito. Tapos yung negative alternation, ito yung voltage na hindi makakapagpa-forward bias sa diode. Kaya yan yung condition na mag-clip siya during that condition. Pag parallel clipper naman, so yan, yung kaninang pinakita ko na examples, yung sa pinakauna, yun ay example ng parallel clipper. Lahat yun. Yan, positive, negative clippers, yan. Pag positive clipper, kiniklip niya yung positive half cycle. Pag negative clipper, kiniklip niya yung negative half cycle. So sa parallel clipper, yan, pwedeng positive or negative ito. So ano yung same lang yun guys, kiniklip niya yung voltage na nakakapag-forward bias sa kanya. Yan, sa diode. Okay, itong condition na to, naka-forward bias si diode during the positive half cycle. Kaya i-clip niya yung positive half cycle. That's the idea. Nakuha po ba? Ito yung circuit condition na, ang connection na during the positive voltage or positive alternation, naka-forward bias si diode. Kaya ang tendency is i-clip niya yung voltahe na yon, yung positive half cycle. Okay? So yun. Kapag may DC bias na, so mag-change na yung value, yung level. Okay, so I think that's all for today. Do you have any more questions or any questions?